Trigonometry. So we're gonna learn the basics of trigonometry. Let me write that down. Trigonometry. Ugh, I can't spell. Trigonometry. So from the prefix tri right here, you can probably guess that this has to do with triangles. This will apply to any type of triangle. Let's go over the types of triangles real quick. Right triangles. They have that one angle that's 90 degrees. What other triangles? Acute, with all the angles being less than 90 degrees. And last but never the least, obtuse triangles. The triangles with that really big angle right here, bigger than 90 degrees. Trigonometry will apply to any of these triangles, but for the sake of demonstration, we're going to just work with this one for now. The right triangle. Okay, so I have my average right triangle right here, and I haven't done anything to it. It's just that normal right triangle that you'll always use. So it's got that 90-degree angle right there, and it has the two complementary angles right here. The ones, if you add them up, you'll get 90 degrees. So what we're gonna do is that we're gonna find names for each of the three sides of this triangle. We're gonna try to name it the best way we can, so we can use the trigonometric functions I'm gonna show you later in this video. So we're gonna be using this angle right here, alpha. I'm gonna name it. Oops, that's a bad alpha. Hang on. Oops. Let me erase that. There we go. Alpha. Okay, so we're going to be using this angle the whole time. We're going to ignore this angle for now. So, how can we label these sides? Well, this side, you might already know, the one opposite to the 90-degree angle, it's called the hypotenuse. So, let's write that down. Hypotenuse. Yep. So, there we go. We can write it like that. And now, what we want to do is we want to name these sides as well. But we know that these are both legs of the right triangle, but we want to be specific. What's so special about this side as opposed to this side? Well, what we can do is we can write this side in terms of angle alpha, this side in terms of angle alpha. So, what can we say about this side? Well, it's opposite to angle alpha. You see how this side doesn't make up the angle alpha, as opposed to these two sides right here. So we will pretty much name it the opposite. The opposite. And now remember, technically you are saying the opposite of angle alpha. You can't just say this is the opposite side, because this angle to this angle right here, this is not the opposite side. It would be this one. But we're gonna get into that a little later. So this is the opposite to angle alpha. Now how about we move on to this side right here? What can we call this one? Well, we have two adjacent sides to angle alpha, correct? We have this side and this side. Now in trigonometry, we're just gonna call this the adjacent. Even though this is technically adjacent to angle alpha, we're still just going to call it the hypotenuse. We're going to always call this one the adjacent. So it's basically the side that's adjacent to the angle, but it's not the hypotenuse. That's what the adjacent is. Adjacent. There we go. And now we have names for all three sides of the triangle in terms of angle alpha. Okay, so now that we have established names for all sides in our triangle, we can create ratios that compare one side to another side. So we're going to be taking pairs of these three sides and then comparing them in a fraction. So for example, I would have, a ratio is like just anything, like x over y. So we're going to have maybe the x will be one of our sides, and our y will be one of our sides. So real quick, I'm going to fill out as many combinations as I can, and I assure you, you're always going to have 6. 6 ratios. Okay, so here I have all the possible pairs you can have, and these are actually all the trigonometric functions that you will find. They all have names, and the ones I want you to focus on are the adjacent over hypotenuse and the opposite over hypotenuse, because in a later video I might show you how these two are used to find any of the other ones, because you can write the other ones in terms of these two. Well, that's beyond this video. But for now, I want you to remember that this one here is called the cosine. This is the cosine. And this one right here, oops, technical difficulties. This is the sine. This is the cosine, and this is the sine. So real quickly here, I want to remind you that it's really important to label the sides of a triangle, and if you do it incorrectly, it's really going to mess you up. So in this triangle right here, you can see that we are focusing on angle alpha here, whereas in this triangle we're focusing on angle theta up here. Remember, these are identical triangles, except in this one we're focusing on angle alpha, and this one we're focusing on theta. So the labeling is going to be very different in these triangles. So for this side right here, in this triangle, this will be the opposite, right? This will be the opposite. Right there. This one right here would be the adjacent right here. Now, if we look at this triangle right here, this is all going to change, because now that we're looking at this angle, the opposite and the adjacent, they're actually going to flip around. So the opposite is going to be down here now. You see, this is the opposite. Oops. And this right here is the adjacent. So you see how when you're focusing on different angles of the same triangle, the adjacents and the opposites, they change. So it's really important to remember how that happens. Like, you can't always go by this being the adjacent and this being the opposite. You have to remember that you're looking at one of these angles. You have to make sure you're labeling your sides correctly. That's all I'm trying to say here. Alright, thank you for watching this video.